Okay. So the last thing that we did before we took the break was that we discussed cardinality and modality. And we identify cardinality as the instances of an entity that participate in the relationship. And we discuss modality as the minimum amount of instances that can participate in a relationship. So cardinality is more on the upper end, as in if there's only one instance or if there's more than one instance, and modality is if there can be 0 instances of a relation, of an entity within a relationship. All right, and I'm going to just ask you all to, I'm going to show you all now what what my preferred method of representing entity relationship diagrams are, which is crow's foot notation. So, because crow's foot notation shows cardinality and modality in a very specific manner. So, we have crow's foot notation. And the crow's foot notation is pretty simple. Okay, so in terms of the entities being represented, right? So we have cardinality and modality. And then we have the crow's foot notation. And the crow's foot notation will go on the side of the entity, right? So just give me 1 second, please. Right. So we have cardinality and modality. So let's say, for instance, we had a one-to-one relationship, right? We had a one-to-one relationship between 2 entities. Oops. I'll change back my pen. We had a one-to-one relationship between 2 entities, and we're representing it like this. Okay, and we're going to focus on what is on the left-hand side here, right? So we have, let me just do it. So let's say, for instance, we have a 1 Okay, so what does this tell us in terms of this relationship? It says, we're looking at it, that what is it? This first entity here participates with 0 or 1 instance of that next entity. So we have entity 1 and entity 2, right? Entity 1 participates with 0 or 1 instance of entity 2. So it's telling me that entity 1 may have an entity 2 associated with it, or it may not have an entity 2 associated with it. But it's telling me here that entity 2 must have an entity 1 associated with it. So you could think of this like as maybe a citizen and a driver's license. A person may have a driver's license, or they may not have a driver's license. Okay, and the most driver's license that you can have is 1. The most driver's license that you can have is 1 driver's license. So a driver's license, however, must have a citizen associated with it. So a driver's license cannot be associated with two citizens. So if I have to put this in crow's-foot notation would look like this. Okay, we have this entity here, and this first circle here represents the modality, and this line here represents the cardinality. And then we have two single strokes here. So what does this say? Right? This is telling me the same thing that I have here, that entity 1 may or may not have an entity 2 associated with it, but the maximum amount of entity 2s that could be associated with entity 1s is 1. The entity 2 must have one and only one entity 1 associated with entity 2. So let me put the example that I had here. Let's say I have a citizen. A citizen, right? A citizen owns a driver's license. Right? I'm not sure I spelled LICENC. Right? Driver's license. So a citizen can not own a driver's license, or a citizen could own one driver's license. You can't have more than one driver's license. A driver's license must have at least one person associated with it, and at most one person associated with it. So that's what will be represented here in terms of crow's-foot notation. If we move forward, if our cardinality and modality, let's take, for instance, a one-to-many relationship. So if I have my entity 1, and we have a relationship, right, with entity 2, oh, sorry, right? If I have 0 or many, right, and entity 2 will have, let's say, 1 or many. If we have to represent an instance of this relationship happening as crow's-foot notation, this is where the name crow's-foot comes in. A many relationship in crow's-foot is represented as such. That little foot here, right? And of course, because this is a, sorry, I had a, this was supposed to be a one-to-many. So again, for entity 1 has 0 or more instances occurring with entity 2, right? Entity 2 has 1 and only 1 instances occurring with entity 1. All right? So we have here entity 1 interacts with entity 2 0 or more times. But entity 2 must have an instance of entity 1. And then, of course, we can have, different instances of this. So if say, for instance, we had a case where the relationship looked like this, and really and truly remember that we really and truly zooming in on these here, not really the instance itself, we will come up, or we will see instances or relationships where these different combinations are happening, right? We will have instances where these different combinations are happening. So we have entity 1 and entity 2. Let's say, for instance, again, it's a one-to-many relationship, but the modalities are different. Okay? So let's say we have an instance where we have 0 or 1 or 0 or many. It would look like this in terms of using crow's-foot notation. And crow's-foot notation, of course, you will put the relationship up here. You have to label your relationship. Okay? So if we have a 0, or 1 here, we have a 0 or many here. This is what this relationship would look like. Entity 1, entity 2. So entity 2 has a relationship where there doesn't have to be another instance of entity 2, or entity 2 has a relationship with entity 1 where they don't have to have an instance of entity 1 happening with this relationship. Okay? And also, there is only, of course, for every instance of entity 2, there's a maximum instance. There are 0 or 1 instances of entity 1. Okay? So this is the participation on both sides for entity 1 and entity 2 is the participation on both sides for entity 1 and entity 2 is optional. Right? And I'm just going to draw one last example in a one-to-many relationship where we have, of course, the entities and they are both mandatory in terms of having to have a relationship. So for here, we can have 1 to 1, and we can have 1 or many. We'll have our relationship labeled. We have entity 1 and entity 2. What does this tell me? That it says for every instance of entity 1, I need to have at least 1 instance of entity 2, although there could be more instances of entity 2. For every instance of entity 2, I could have 1 and only 1 instance of entity 1. I cannot have an instance of entity 2 and entity 1 does not exist. Okay, so that's kind of like our car example earlier, right? You can't have a vehicle in the system without an owner of this vehicle, right? And lastly, representing the many-to-many, representing the many-to-many relationship. Okay. And of course, a lot of times when we draw this many-to-many relationship between entity 1 and entity 2, and you annotate many-to-many, it's represented with an M and an N, right? So this is a many-to-many relationship. A lot of the times, just because they are on 2 different sides, it's one side is M and the next side is N, right? Indicating like a variable number amount for the many-to-many. You're not going to lose points though if you put M on this side and M on this side and something so. But you will also see it noted like this at times. All right? So if it is that we see this relationship as a crow's foot notation, okay, we'll have our circle with our and this is entity 1 and entity 2. And of course, we will have our varying, what you call it? Different combinations of these. Okay, this is not like the only one. It depends on the situation. So you can have a many-to-many relationship where the modality is 0. You can have a many-to-many relationship where the cardinality, sorry, with the where the modality is that you have an instance in each case. We have any questions so far? We're going to do an example. But any questions so far on representing as crow's foot or using cardinality and modality like this? I will go so far as to say whichever one you are more comfortable with, you can utilize. So if you want to utilize the notation on this side, that's, with me, that's fine, as long as you implement it correctly. Likewise for crow's foot notation. But the thing is, I'm showing you both so that you can, when you are doing a study on your own, if it is that you see one notation or the other, you are able to understand these notations. Does anybody have any questions before I show an example?
So if you could scroll down, that's how many you have there, the last one,
Yeah, this is a many-to-many.
and that's a 0 to many you have there.
Which, no, this is a many-to-many. But what the modality is saying is that entity 1 can relate to 0 or more instances of entity 2. But entity 2 must relate to at least one instance of entity 1.
Okay, I was talking about the diagram on the left. We have 0 dot 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 n as a n or
Right.
m.
Yes. So that's telling me that. So entity 1 has a relationship with 0 or more instances of entity 2.
So
Okay, let's.
within the exam, would they state which notation they want, or you could legit
No,
use anyone?
you can use whichever one is preferred. Within the exam, they typically don't really require you to work out the modality. They more focus on the cardinality. But for your SBA, I would prefer that you have some sort of modality inside of there. He isn't always, and I mean, I don't want to be saying it on a recording or anything so, because then I don't want anybody coming back and saying, well, CXC not looking for modality, Mr. Valdez says so on a recording dated the 14th of October 2021. But what happens is that when CXC corrects, CXC really and truly, even in their descriptions, they allow you to assume the modality, and you can get full marks without including the modality. But I mean, in the effort to pursue good database design, I would say practice with the modality. Okay. But if in the exam per se, a little miss. All right. In the exam per se, really and truly, CXC is just looking for your relationships, the correct identification of entities, and correct expression of many to one or one to many, etc. All right. Any other questions before I copy in the sample question that we're going to work on? This question is from 2011 2011 paper. Any more questions or no?
So I know you mentioned databases. Would we have to use Access for computer science too? Because I know in IT, while doing ERDs, you're also learning Access for the database.
No, we don't.
Okay.
We don't. I will teach you a bit about database and SQL because that is now included in the syllabus. We will do that actually, I believe, under module 3. Right? We'll do that under module 3. Why is my stuff not copying in? Yeah, we'll do that under module 3, but there's no implementation that has to take place in terms of actually building a database. I wanted to, and I actually asked the network admin in school when they were setting up the computer earlier this term to install MySQL on the computer systems. So if we do return to school and there is time, I would make us actually run a couple commands in MySQL to create a database and to add tables, drop tables from a SQL perspective. If not, I'll just teach it more from a theory perspective if we have to do it online. But it's not that you have to be able to implement it. I want for you to be able to implement it. So again, when you reach the university, you have a bit of familiarity with doing such a task. Okay, because in university they might use Postgre or MySQL or Oracle, but at least if you did it once, you have like a kind of basic understanding of what's going on with the system, you know?
Yes, sir.
All right. So we have a certain university. This is a nice, simple one, right? I always find that the entity relationship diagrams in computer science, they tend to be what I consider easy marks. This is 12 marks out of 150 marks, right? So that is about 7% of your exam. If we estimate in 6 or 7% of your exam. Once you could draw a decent entity relationship diagram, then that's easy marks locked. All right. Well, this 25 marks is because I took it from the bottom of the question, and that's not really relevant to us here, right? All right. So we have a certain university has a number of colleges. Now the first thing we want to do is go through and identify entities. So a certain university has a number of colleges. Each college has one or more departments. A lecturer is hired by one or more departments. A department can teach in many courses, and a course can be taught by one or more lecturers. The following information is stored on a course. So these here are attributes. I would always say, do not, when you are answering questions for CXC, give more attributes than necessary. If they tell you what attributes are there, then put it. Everything else you can put a primary key attribute for as a unique identifier. Okay? So what is the first, and I expect some people to tell me something that is not an attribute here because you might think it is, but it's not. What is the first entity, sorry, not attribute, entity that you see they've identified here for us? Anybody, you can tell me what you feel the entities are in this.
So the lecturer.
Okay, so a lecturer. That's the first entity that you see that you show as an entity. What else do we have as entities? What are we keeping information about? Yes, Shana?
So it's at the college.
Right, so we have colleges. What else do we have to store information about here?
So I'm not sure about the course.
A course, okay. Anything else?
The department.
A department. I think that those are our entities, right? So our entities are in green. Our attributes we can put in red. What attributes were identified in this what you call it? What attributes were identified in this description here? Attributes is information about an entity. So where did we get information about any specific entity?
At the end, the
Just
code name
I
of
didn't
the course.
Right. So the attributes are for the course, this code name, and the credit hours. And a primary key is a unique identity attribute. Right? So each what you call it? Each entity will have something that identifies each instance of it in the database uniquely. In this case, for course, it's code. Okay, good. So once we've identified our entities and our attributes, we can identify some relationships. So let's see if we can identify some relationships here. Where do relationships occur? They told us about some relationships inside of here. They said a certain university has a number of colleges. University, not an attribute, not an entity. Why is university not an entity?
So to me, university seems like fairly broad hierarchy or everything underneath. So it won't really classify as an entity, I think.
Yeah, sir, I agree with Hazard there.
Hazard, you're 100% correct. There is only one university in this scenario, and the university is keeping information about colleges, department, lecturers, and courses. Right? So the university, there's no need to keep information on the university because university is that overarching, I don't want to use the word entity, but the university wants to keep information on these specific entities. There is only one university. If there is only one, if you have an entity that there will only ever be one attribute for, one information entry for, one tuple, then chances are that the system does not need to keep information about that. Okay, so you guys are going well. I'm feeling proud, right? That you know, sometimes people say university is an entity here, and we have that discussion and that fight down. But the university this is the university's database that we are creating here. So we identify that each college has departments, right? A lecturer is hired by a department. Okay, a department offers many courses, and a course has a relationship, is taught by lecturers. So these are our relationships here. So this is where we can see some sort of, some sort of relationship, some sort of I need a synonym for relationship, some sort of interaction, some sort of, interaction between two entities. So now we could draw our database, diagram, our entity relationship diagram. And please forgive me, we might go about 2 or 3 minutes over the 11 o'clock. So we have a college. And remember, we keep it singular. A college and a department has a relationship. So a college, right, contains departments. How many? And there are things you have to make assumptions about in this. All right. Some things were told to us explicitly, and some things we have to make assumptions about. Now, this is where modality comes into play. Can a college have 0 departments? Can a college have 0 departments?
No, sir.
No. So in terms of our modality, we would assume that a college will have at least 1 department, but a college could have more than 1 department. And a department, does a department must belong to a college? A department must belong, can a department exist without belonging to a college?
In this scenario, no, sir.
No. So a department must belong to a college. Can a department belong to more than 1 college? This is where we make an assumption.
Yes,
we could assume that a department is shared between colleges. So we could say, okay, right, a specific department like the language department might belong to the South College and the North College. Okay, so we can make that assumption because it was not told to us explicitly in the example. So let's move on. A lecturer is hired by 1 or more departments. So the next thing that we have is a lecturer. And a lecturer is hired by 1 or more departments. So a department, you have the relationship, hires a lecturer. A department could hire, well, I think a department needs at least 1 lecturer, but a department would hire 1 or more lecturers. And right, and we say here a lecturer is hired by 1 or more departments. A lecturer needs to work with a department, and a lecturer could work with more than 1 department. Okay? And we have a department can teach many courses. All right, so a department can teach many courses, but they say a course can be taught by more than 1 lecturer. I don't want the relationship with the same name. So I'm giving a new name to this relationship. So I have courses here, or course, and I could say that a department will offer a course. So a department offers a course, right? A department has to offer at least 1 course, and a course, a department will offer, of course, many courses. When we read in this back, a course is offered by, right? A course should belong to 1 and only 1 department in my eyes. This is an assumption that I am making. So the department, North English and South English, they might have their courses, but a course itself, you can't really have a course within a department in 2 separate places. That's how I see it, right? So a course shouldn't be a course must come from a department. That's why we say the modality is one. And the course should belong to, if this is the intro to English from the North Department, then we have an intro to English from the South Department. That's how I'm separating it in my head. So a course is offered by one and only one department. Now look at the way that this is, course, lecturer. I'll go with the down reading. So I'll say, okay, a course can be taught by one or more lecturers, right? So a course is taught by, right? A course must be taught by at least one lecturer, but a course could be taught by multiple lecturers. So we could have different instances of that course being taught by more than one lecturer. Okay? A lecturer, however, can a lecturer teach, does a lecturer have to teach a course? Does a lecturer have to teach a course? I would say no. Right? I don't know why this thing not moving. Right. So a lecturer does not necessarily have to teach a course at a given time, but they could teach more than one course as well. So a lecturer could teach 0 or more courses. Understood?
So, I have a
And I would
question.
say that this here,
So is, if based on your assumption, once it makes sense, can it work? Because when I was thinking about it for the lecturer teaching the course, I had one and only one. As in, like, you'll have like a physics lecturer. He wouldn't be able to teach an English course. So you'll have him teaching at least one course and then, well, only one because it's his subject or his field.
but then you might have two instances. Let's say, remember, and this is where we come back. If we have North Physics Department and South Physics Department, does this same lecturer teach the North Physics Introduction course and the South Physics Introduction course?
Okay,
Maybe
so
he
I
could.
understand when you're coming from that
Moving
perspective.
between North and South. Right. So this is where, but then, maybe this semester, we don't have any courses in biology being taught. So while a lecturer belongs to the biology department, the lecturer for biology is not teaching any courses right now as well. So that's where the 0 comes up in terms of course. All right, so a lecturer could be there, but they just don't have any courses. All right. Any more questions on this? Any more questions?
What happened to the attributes, sir?
Yes, thank you very much, Josiah. Right, so I was about to leave it without the attributes. The attributes says that for the course, we have a code, and the primary key attribute is always underlined. And remind me next class to go through attributes representation with you all. A course must have a name, and a course must have credit hours. So these are the 3 attributes that they've asked us for here. Now, if we want, we can do this, because this is one thing we know that each attribute will need. Each college will have its ID, each lecturer will have its ID, and each department will have an ID. But outside of this, we were given nothing more in terms of attributes, so do not put anything more. The thing is that we know that every attribute, every entity must have an ID attribute. So it's safe to do this. But anything beyond this is a little risky. Are you with me? Because you're making assumptions about things that we'll say. And that's now over assuming. All right, so next class, I want to talk to you all. We'll go through this again. I do want to put up the assignment with the DFD. I'm tempted to put in a little ERD question there as well, right? I will allow you all to refine your question or answer if you want to try and maximize marks. So I'm going to put up a little assignment. We will try it, you know, and next class, I'm going to talk to you about attributes. That is, next class, of course, is, oh no, next class, no. I know what I'll do. I'll put up the assignment and next class, we will focus on, working through the assignment. And next week, Thursday, is when we will get into going over this again, do a recap, and we will take a look at the types of attributes that exist, etc. All right, so that's it for you and me today. Are there any questions? Any questions? All right, so I have a question for you all. Let me stop you could put it on the recording. Who feels like they learned something today? No hands? No hands. All right. So entity relationship diagrams, they don't hit your head as much as data flow diagrams. They're a little more friendly. They're friendlier than data flow diagrams. And we'll continue to work on them. All right. So I'm going to stop the recording now.